Chapter 4, Section 2, Exponents and Scientific Notation. So in this section, we're going to continue with our power rules, our exponent rules. In the previous section, I taught you, I think, 4 or 5, and so now we're going to continue on with that. And remember, you can put all of these rules on your index card for your test. So raising powers to powers. So this is the next rule that we have. This is called the power rule, and the reason being is because you have a power on the inside raised to another power. Well, when you have a power to a power, you multiply those exponents. So we haven't multiplied the exponents just yet. So now we're going to. Power to a power means we're going to multiply. And so here we have x to the 4th, a power on the inside, raised to an external power of 5, which means you're going to multiply those exponents and get x to the 20th. So here, if I have 3 to the 4th raised to the 5th, keep the base the same, and you're going to have 3 to the 20th power. Here, same thing, keep the base the same, power to a power, negative 3 times 4 is going to be negative 12. Well, in the last section, we learned that when you have a negative exponent, you have to fix it, and your answer needs to be with positive exponents only. And so we're going to have 1 over x to the 12th. For letter C, you have y to the negative 5th to the negative 3rd, so keep the same base. Negative 5 times negative 3 is going to be a positive 15. For letter D, you're going to get x to the negative 32, but we need positive exponents, so we're going to have 1 over x to the positive 32. And then another one we're going to have is product to a power rule. So what that means is on the inside, you're multiplying things. You have multiple things that you're multiplying, and all of it's going to be raised to an external exponent. Well, when that happens, what's going to happen is you're going to take each factor, and each factor gets that exponent. So, to raise a product to a power, number 1, distribute the external power to everything inside the parentheses, and then follow your rules for coefficients raised to a power, and then follow rules for power to a power for variables. So, for example, letter A, step number 1 says to distribute the external power to everything inside the parentheses. Well, you have to understand what everything means. Inside these parentheses, we have 3 factors. We have a factor of 2. We have a factor of x to the 5th, and we have a factor of y to the negative 3. Each one of those 3 factors gets raised to the 4th power. So we have 2 to the 4th power, we have x to the 5th to the 4th power, and we have y to the negative 3 to the 4th power. So each factor on the inside gets raised to the external power. And then from here, we're just going to simplify. So 2 to the 4th power is 16. And then x to the 5th to the 4th is x to the 20th. And then y to the negative 3 to the 4th is y to the negative 12. Now your answer needs to have positive exponents only. So remember, if you don't see a fraction, make it into a fraction. If you see a negative exponent, just make it into a fraction if it's not already a fraction. If it has a positive exponent, leave it on top. If it has a negative exponent, push it to the bottom. So 16 has a positive exponent of 1, so we're going to leave it on top. X to the 20th is a positive exponent, so we're going to leave it on top. But y to the negative 12 needs to be pushed to the bottom to a positive 12. Alright, let's try again. So we're going to have 5 squared, so 5 to the 2nd power, times x to the 5th to the 2nd power, times y to the negative 6 to the 2nd power, times z to the negative 3 to the 2nd power. So inside there are 1, 2, 3, 4 things that we're multiplying together, and all 4 things get that external 2. So 5 squared is going to be 25. X to the 5th squared is going to be x to the 10th. Power to a power, you're going to multiply. Y to the negative 6 squared is going to be y to the negative 12. Z to the negative 3 squared is going to be z to the negative 6. And again, positive exponents stay on top, and negative exponents get pushed to the bottom. Alright, for letter C. Letter C says we're going to take negative 8, or negative y to the 8th, and raise it to the negative 3rd power. And so what we're going to have is negative y to the negative 24, which is going to be 1 over negative y to the positive 24. All right, letter D. Everything gets raised to the negative 3 power. So we have negative 3 raised to the negative 3 power. We have x to the 2nd raised to the negative 3 power. We have y to the negative 5th raised to the negative 3 power. And so negative 3 to the negative 3 power is going to be 1 over 27, or negative 27, negative 27 to the positive 3 power. And then x to the 2nd to the negative 3 is going to be x to the negative 6. And then y to the negative 5 to the negative 3 is going to be y to the positive 15. And so we need that x to the negative 6 to go to the bottom as well. So we have y to the positive 15 over negative 27 x to the positive 6. So why did I put this negative 27 on the bottom here? Well, look at this. Negative 3 to the negative 3 power is the same as 1 over negative 3 to the positive 3 power. And 1 over negative 3 to the positive 3 power is the same as 1 over negative 27. And so that's why the negative 27 was on the bottom initially. And so here I just used my power rule. X to the 2nd to the negative 3 is x to the negative 6. And then I pushed it to the bottom because it had a negative exponent. But here for my y, the negative 5 times negative 3 is positive 15, so it stayed on top. Okay, raising a quotient to a power. What this means is I have a quotient on the inside. So I'm dividing things on the inside, raised to an external power. Well, again, everything on the inside gets raised to that external power. Now, with quotients, and you have a quotient raised to a negative exponent, the easiest thing to do is go ahead and flip the inside and raise it to a positive exponent. In other words, take the reciprocal of what's inside, raised to a positive exponent, and then distribute your power. And that's the easiest thing for a quotient. Now, I didn't do that here. So, for example, I did not go ahead and put 1 over negative y to the 8th to positive 3. You could, and you're going to get the exact same answer. Same thing here. You could do 1 over all of this raised to the positive 3 power, and you're still going to get this answer. So it's your choice. You figure out what's easier for you. So again, here for letter A, everything on the inside gets raised to that external 2. And so now I have a power to a power, so I'm going to have x to the 12th over, not 10, sorry, over 25. 5 squared is 25. That looks like a 6. There we go. Now, for letter B, you have a 2 to the 3rd power times t to the 5th to the 3rd power over w to the 4th to the 3rd power. So 2 to the 3rd power is 8. T to the 5th to the 3rd power is t to the 15th. You're multiplying those exponents. Power to a power you multiply, and you're going to have w to the 12th. Now, letter C is what I was talking about. Since I have a quotient raised to a negative exponent, what I'm going to do is I'm going to flip the inside. Everything on the inside stayed exactly the same. I just flipped it and raised it to a positive 2. And now I use my quotient rule, so I have 3 to the 2nd power over x to the 4th to the 2nd power. And so 3 squared, 3 to the 2nd power, 3 squared is 9. X to the 4th squared is going to be x to the 8th. And that brings us to scientific notation. So scientific notation is for a number is an expression of the type m times 10 to the nth power, where n is an integer. In other words, n is going to be either a positive or negative number, and m is greater than or equal to 1 and less than 10. So m needs to fall between 1 and 10. And m is expressed in decimal notation. So 10 to the n power is also considered scientific notation when m is equal to 1. So a positive exponent, and this is how you're going to keep this straight, because remember, n can be positive or negative. That's what the word integer means. N can be positive or negative. And so it gets kind of confusing which way, or what do I have? Which way am I going to move this decimal? So remember this. A positive exponent in scientific notation indicates a very large number, something greater than or equal to 10. And a negative exponent indicates a very small number, a tiny, tiny decimal between 0 and 1. So keep that in mind. Positive exponent is a very big number. Negative exponent is a tiny, tiny decimal. And so this is what I'm going to ask you to do. I'm going to ask you to convert decimals to scientific notation. Well, remember, our goal is a number between 1 and 10, always times 10 to a positive or negative number. So what we're going to do is we're going to take this decimal and we're going to move it until we have a number between 1 and 10, which means I'm going to move it here. I'm still not there, 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 and there. And so I have a number of 5.17. That's between 1 and 10. Now, times 10 to the what number? Well, I started out with a tiny, tiny decimal, and remember what I told you on this previous slide. If you see a negative exponent, you're talking about a number between 0 and 1. Well, our initial number, 0.000517, falls between 0 and 1. So that tells me I'm going to have a negative exponent. So negative what? How many times did you move the decimal? 1, 2, 3, 4. So 5.17 times 10 to the negative 4 power is what your exponent is going to be. And so this is scientific notation. Now look at letter B. I don't see a decimal here. Well, if you don't see a decimal, where is the decimal always understood to be? It's always understood to be to the far right. So now let's start moving this decimal to the left until we hit a number between 1 and 10. So follow along with me and think when I've got a number between 1 and 10. And I think that'll do it. So if we have 5.23 and we get to drop all those other zeros, 5.23 times 10. Now, are we going to have a positive exponent or a negative exponent? We started out with a very large number. 523 million is a very large number. And so we know we're going to have a positive exponent. How many positive? Well, how many times did you move the decimal? 1, 2, 3, 4, 5, 6, 7, 8 times. So it's times 10 to the positive 8 power. Letter C. So again, our decimal, we don't see 1, so we're going to put 1 to the far right. 14 is not between 1 and 10. It's really close, but it's not between 1 and 10. So we need to move the decimal one more place, and we get 1.4. Now that's between 1 and 10. Times 10 to the positive 1 power. 1.4 times 10 to the positive 1 power is what our exponent's going to be. So let's go the other way. What if I give you scientific notation and I ask you to convert to decimal notation? Well, again, here's our decimal point, and we see that we have a positive 11, which means my end result should be a really, really, really big whole number. And so think about which way to move the decimal. If I move the decimal to the left, that's going to give me another decimal, and that's not what I need. But if I start moving that decimal point to the right, my number starts getting bigger, because if I go here, it's 68, 689, 6,893, and so on and so forth. And so that's what I need to do. I need to move the decimal 11 places to the right. So that's going to give me 6893, moving the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So how many zeros do I need? 1, 2, 3, 4, 5, 6, 7, 8 zeros. And so that's a really big number, and that's what you're going to get. Now look at letter B. I have a negative exponent, which means I'm going to expect a decimal, right opposite of what I got in A. So this time, instead of moving to the right, I'm going to move to the left. And we're going to move 5 times. So we're going to go 1, 2, 3, 4, 5, and put our decimal point there. So how many zeros do we have? 1, 2, 3, 4. So it's going to be 0.0000567. And so you see we get a tiny decimal between 0 and 1. Now, 10 to the negative 4. 10 to the negative 4. Something is missing. Because remember, scientific notation is always m times 10 to a number. And so here is our 10 to the n, 10 to the negative 4. So m is missing. Well, remember, m can be equal to 1. And I can multiply 1 times anything and not change a thing. And so this can be understood as 1 times 10 to the negative 4. Well, if I do that, the decimal is understood to be here, which means I need to move the decimal 4 places to the left. 1, 2, 3, 4. And so what I'm going to have is point, how many zeros do we do? 3, 1, 2, 3, 1. And so that's going to be your decimal notation. The next thing we're going to do with scientific notation is to multiply, and this is where our power rules come into play. So to multiply using scientific notation, you're going to multiply m times m, remember here, and then you're going to multiply n times n. Then write it in correct form of scientific notation. So let's do that. Let's multiply m times m. So we're going to have 1.12 times 5. And we get 5.6 times. And remember, when you multiply powers with like bases, the powers stay the same and you add those exponents. So negative 8 and negative 7 is going to be negative 15. And then you need to check and make sure that this is in scientific form. Well, m has to be between what two numbers? 1 and 10. So 5.6 is between 1 and 10, so we're good. And so this would be your answer. However, look at B. Let's go ahead and multiply 9.1 times 8.2. And this time I get 74.62. And we know that that's not between 1 and 10. And so we're going to have to move that decimal. But let's go ahead and take care of the powers. So 10 to the negative 17 times 10 to the third. When you multiply powers with like bases, leave the base the same and add those exponents. So we have negative 17 plus 3, which is going to be negative 14. Now, we have a big number here. 74 is above 10, which means if I move the decimal 1 place to the left, that's going to push my exponent to a plus 1. So negative 14 plus 1 is going to be 7.462 times 10 to the negative 13. So let's talk about that one more time. Remember, 74.62, this m needs to be between 1 and 10. So I know that I need to move the decimal 1 place to the left. If I move the decimal 1 place to the left, that's going to be a positive exponent. And so I'm adding 1 here. So negative 14 plus 1 is going to be negative 13. Alright, so what about division? Well, same thing. To divide scientific notation, you're going to divide m divided by m, and then your power divided by power. And so let's do that. 4.2 divided by 2.1 is going to give me 2. And that's between 1 and 10, so we're good there. Times, and remember, when you divide powers with like bases, the base stays the same, and you subtract top power minus bottom power. So 5 minus 2 is going to be 3. And that's correct scientific notation because m is between 1 and 10. However, let's go here. Letter B, 1.1 divided by 2.0. And that's going to give us 0.55 times 10, negative 4 minus negative 7, negative 4 minus negative 7 is really going to be negative 4 plus 7, and so that's going to be 10 to the third power. Now, This time I have a decimal, which means to get this in proper scientific notation, I need to move this decimal one place to the right. So now I'm going to have 5.5. But when I move that decimal to the right, that's going to be to the -1. So 3 minus 1 is going to be 2. So again, you have to remember, if you start with a tiny decimal, you have a negative exponent. So when I move this to the right, if I start with a decimal and I move it to the right, that's going to lessen this by 1. However, if I have a number bigger than 10, I have to move the decimal to the left, in which that's going to make that bigger by 1. So you have to keep that straight in your brain. Alright, so I would like you to try these problems. The answers are on the next slide. So if you have problems, bring them into class.